as I was doing these notes, my computer died and I tried to plug it in, but everything shut down. So I am going to finish up these 8-2 notes, and it's part 2 of 2. The first part was multiplying, so simplifying rational expressions and multiplying, and the second part was dividing rational expressions. So, and just in case you're joining, there is another part to this video, and I have it labeled as like the first section or the first half. So again, we talked about our rules, we went through these examples completely, talked about domain restrictions. Instead of dividing, we multiply by the reciprocal. We're going to flip our fraction, and then we can cross cancel. Same idea of factoring each piece, but we also want to make sure we multiply by the reciprocal. And we also talked about domain restrictions coming from the 3 pieces. The denominator and denominator cannot be 0, but we also now have to consider that this numerator is truly a overall denominator because we are dividing by this piece. So 16 will never be 0, we are okay, but over here we do have to consider that this could be 0. And again, domain restriction comes from that factored answer before anything was canceled. So I just wanted to show that. You could pause the screen if you missed the first video, or you can go back and find it. It'd be better to watch the first part of this before you jump to the second. There were some check it out examples for some extra practice, and we were working down here when my recording stopped. So we talked about we could cross multiply here and solve, but sometimes that gets a little bit messy. So we went ahead and we factored and found that we can cancel this and got a simple equation to solve. So these are simple rational expressions, or simple rational equations. And then we talked about the domain restriction, and we want to check on that. And that domain restriction is important. And so we had this example where the x minus 1's canceled, and we got that x could be 1. The issue was the domain restriction is that x cannot be 1. And so this is where the video stopped. It stopped because this cancels out. X cannot be 1 because it was a domain restriction. That leaves us with the null set, which is really meaning there are no solutions. So you could write out no solutions or the null set, and we have that domain restriction, what caused our answer to cancel out. Now sometimes you'll have 2 outcomes and one cancels out, so we'll still have an answer. All right, so we have 2 more like this to practice. So again, these are simple equations. So go ahead and pause the recording now, and it'd be a good time for you to try these problems. All right, so if you paused it, let's go ahead and work these out. First thing I want to do is factor this. It'll be x plus 4, x minus 3, and that will be over x plus 4, and it's equal to negative 7. But before I worry about the equation, I'm going to cancel these like terms, and I'm going to get x minus 3 is equal to negative 7. And I'm going to go ahead, I'm going to add the 3, and I get x equals negative 4. Now, before I think I'm done and I circle my answer, I want to check for a domain restriction. And my domain restriction here states that x cannot be, right here, x cannot be 0. And so that means x can't be negative 4. So we have, again, where we're actually throwing out our answer because the domain restriction interferes with that. And so here again we have no solutions, and that is due to the domain restriction not working in the original problem. Okay, another problem here, we're going to go ahead and factor the top. It's a difference of squares, 2x plus 3, 2x minus 3, all over 2x plus 3, and then that's equal to 5. And so our factors that are common cancel out, and we're left with 2x minus 3 equals 5. Okay, so we go ahead and solve this by adding 3, and we get 2x equals 8, divide both sides by 2, a little ahead of myself, and I get x equals 4. All right, so we need to check our domain restriction. What can't x equal? Well, my denominator in its factored form before we canceled can't be 0. And so that would be that we would subtract 3 and divide by 2. So x cannot be a negative 3/2. So that does not interfere with my answer. And so there we go. All right, next problem we have is from the textbook, and it is an error analysis problem. It says two students simplified the same expression, which is incorrect, and to explain the error. Okay, so when I first look at this, they both have the same problem, so I want to look for that. The next thing is this one has an x plus 9. Okay, that has x plus 9 on top. X minus, okay, so everything's factored the same. They cancel the same thing out. Okay, the difference is in the answers. So whose answer is wrong? Answer A is wrong. Answer B is correct. And this is one of the things that I've pointed out. When these cancel out, x minus 9 is left, but it's left in the denominator. Okay, so it has to be a 1, you know, x plus 9 goes in itself one time, so that is why it's left in the bottom, 1 over x minus 9. If you want a domain restriction on here, domain restriction, x cannot be 9 or negative 9. All right, so we weren't solving anything, we were just checking for that. All right, so that's really it for the lesson. But I have these that are called challenge problems. I don't think they should be that challenging, but they are harder than the ones that we did because it's using some prior knowledge, or like number 3 is a pretty hefty looking problem and we have more than one operation. So again, this would be a great time to pause the recording and give it a try yourself to see how you do, and then you can come back and check it with me and see how you did. All right, so I'm ready to go. What makes this challenging is this is a difference of cubes, and we haven't come across one of those yet. However, it should be in your prior knowledge base. So how do I factor that? Well, we had a factoring chapter or factoring sections in chapter 5, and we also did a factoring review, which would be very helpful at this point if you're struggling with these. So up here, I'm going to use SOAP, same, opposite, always positive. I'm going to take the cube root of 8x to the third and drop it as 2x, and the cube root of 1. I had alluded to that acronym that helps with the letter. So if you say it out, it is Crazy Rudolph and Santa Plows Snow. So the Crazy Rudolph is the cube roots drop into here, and the Santa Plows Snow goes into here. So square that, which is 4x squared. Plows would be the product, so 2x times 1 is 2x. Again, we already had the sign set. And then square that for the snow, and that's 1. So that's the numerator factored. The denominator does not need factored, it's just x plus 2. And then the top here is a difference of squares, x plus 2, x minus 2. And the bottom, it's going to take a little bit of effort to factor because of that 2 out front, but it'd be a 2x and a 1x. They're both going to need to be negative signs, and we want that to be a, I believe, a negative 1 and a minus 2. Better double check ourselves. So here's my 2x squared, here's my negative 4, my negative 1, there's my negative 5, and I get my positive 2. So we've got that. Okay, so now it's all factored. Again, I think the challenging part was your cubic. And now I can cross cancel. So 2x minus 1 cancels with 2x minus 1. The 2x plus 2 cancels with that. And we have one more thing that cancels. I'm trying to show different ways so you can see what pairs up. So what is left is this 4x squared plus 2x plus 1. All right, so let's talk about the domain restrictions. What can't x equal? All right, well, this was a multiplication problem, so I didn't do any flipping. My domain restrictions come from this denominator and this denominator. Those are just the things we're dividing by. So x cannot be negative 2, all right? And x cannot be positive 1/2 or positive 2. So positive or negative 2 or positive 1/2. And that is our final answer. All right, so what makes number 2 challenging is this negative exponent. A negative exponent tells you to take the reciprocal. So we're going back to our exponential properties. A to the negative n is equal to 1 over a to the positive n. So what would happen with this is to deal with this negative exponent, I would flip it. But then what's going to happen is I have division, so it's actually going to flip back. Okay, so that's something different. Now, if this had a power of -1 on it, we would flip it and it would stay. So let me go ahead and just rewrite this. But really, some of you have got that and you could jump right into the problem. I'm going to leave the division symbol because I have to evaluate by order of operations exponents before I can do multiplication division. So I'm going to do my exponent where I'm going to flip it to be x plus 4 over x squared minus 9. Now I've dealt with that power of -1. Now I'm going to deal with the division symbol. So I'm going to go ahead and jump right into my factoring. So that'd be x plus 4 and x minus 4. And then down here would be x minus 3. And I'm going to multiply by the reciprocal. So it's going to flip right back up and I'm going to factor it x plus 3, x minus 3. And then the denominator is x plus 4. Okay, so now that I have that, I can cross cancel the x plus 4s. I can cross cancel the x minus 3. And it appears that I am left with x minus 4, x plus 3. And so now that I have that, I'm going to go ahead and FOIL that out to clean it up. And that gives me an x squared, a 3x, and a -4x is a negative x minus 12. And let's come up with our domain restrictions. The domain restrictions are going to come from your original denominator. Okay, can't be 0. Now this was in the denominator. And so we're talking about both of these pieces here. You're never truly dividing by the x squared minus 9. So we're just doing these two pieces here. Okay. And so we have that it cannot be 3 or -4. And that's due to the power changing that. Okay, so we've got this next problem. It's pretty big. So there's a couple challenges here. One challenge is that I have 4 terms. Okay, and that means I'm going to factor by grouping. There's no GCF there. I have another problem with 4 terms. So I'm going to do some factoring by grouping. The other challenge is that I have division and I have multiplication. So I'm going to change that sign and I'm going to flip just this fraction. This one does not flip. So I need to take a minute and I need to do my factoring by grouping for each of these. So I'm going to take this off to the side. The x to the 5th minus 4x to the 3rd minus x squared plus 4. I'm going to go ahead and group that. Again, if you're not familiar with factoring by grouping, there are recordings out there, but there's also the factoring review. So I'm going to group this and I'm going to put that negative sign in there, squeeze my own plus sign in, take out the GCF, x squared, oops, sorry, x to the 3rd. I'm left with x squared minus 4. And then I can't take something out of here, but I'm going to take out a -1. You always have to take a 1 out. And I'm left with positive x squared minus 4. All right, so what do these have in common? Well, they have x squared minus 4 in common, and what's left over is x to the 3rd minus 1, which is crazy because this is a difference of squares, and that is a cube. So this is going to go right back, and I'm going to go ahead and jump right back to factoring this. I'm going to come over here, and this is going to be x plus 2, x minus 2. Okay, so that's this part. I'm just bringing it back to not rewrite it. And then I have this, and I think I'm going to run out of room. So let me slide this further over. Hold on 1 second here. Let me go way over here. All right, so I'm going to have x plus 2, x minus 2. All right, then I'm going to have my cubic. So it's going to be x minus 1, and it's going to be x squared. We'll set our sign, sorry. So same, opposite, always positive. And then I take my cube roots of the x third and 1, and then I square the x and I square the 1, and I get the product. Okay, that's factored. Now this looks like it would keep factoring it, but does not. Now I need to do the bottom. Okay, so I have to do this bottom, and I'm 100% going to run out of room here. And so I'm going to come off to the side here, and I'm going to do that denominator, which is x to the 3rd minus 2x squared plus x minus 2. All right, so let's go ahead and group those. There you go. And take out the x squared, and what's left is x minus 2. And there's nothing to take out of here, but I can take out a 1, and I'm left with x minus 2. So what do they have in common? X minus 2. What's left over is x squared plus 1. Now, The x minus 2 comes over, but we want to take a look because I have an x squared, but because it's x squared and it's plus 1, it doesn't factor. There are no factors of 1 that add up to 0. So that's going to stay as an x squared plus 1. Okay, my division symbol is now going to flip to multiplication, and I'm going to multiply by the reciprocal. So this is going to come up top as an x plus 1, x minus 1. I was a little too generous in my other writing. This is going to be on the bottom, but notice that I have a 3x that I can take out, so I'm left with x squared plus x plus 1. Okay, so I took out the GCF thinking that this would factor, but there are no factors of 1 that add up to 1. So this is going to stay, which actually is right there. So I have down here just a 3x, and then the x squared plus x plus 1. Okay, last piece, let me see if I can squeeze it in here, was multiplication, so I'm going to leave it, and the 6x stays up here. And let's see if we can factor this. Looks to me like an x minus 1 times x minus 1. Now, this is a perfect square, and we would normally write it as x minus 1 quantity squared, but I want to see the two pieces as I cancel. Okay, so since this is all multiplication, and I wanted to note the different multiplication since we flipped it and leave that one alone, we can cancel any top to any bottom. So this piece definitely cancels with this piece. And I have an x minus 1 that cancels with a 1 of those x minus 1, so that's extra. I have an x minus 2 that can cancel with an x minus 2. That's x plus 1, and that is x squared, so that does not cancel. The only other thing I want to check on is the 3x and the 6x. So the x's cancel, and the 3 cancels to 1, and that cancels to 2. So what I'm really left with in the top is x plus 2, x plus 1 times 2. And what I'm left in the bottom with is an x squared plus 1 and an x minus 1. So I'm just taking a minute to double check myself to make sure that that's really what I'm left with. So you want to double check that you didn't miss anything. And if you miss something, you could always look for it now because we have the pieces. And at this point, we're going to multiply it back out. So I'm going to go ahead. This is my final answer of leftovers. And then we're going to multiply it out. So I'm going to leave that 2 out there. I'm going to FOIL that and get x squared. 1 and 2x would be 3x plus 2. And then in the bottom here, I'm going to get an x to the third. And then I'm going to get a negative x squared. I'm going to get a positive x and a negative 1. Okay, so one final step for my final answer. 2x squared plus 6x plus 4 all over. And I think this is what I should have left down here. I feel like I might have missed something. Let me see here. Okay, I found my mistake. I had ignored this. This x minus 1 should have canceled with the x minus 1. So I have my x plus 2 and my x plus 1. I just didn't see that guy, and I thought I had something else that canceled out. So let me fix this. I wish I could take the time and edit the videos, but here's where we're at. And so I'm left with the bottom of x squared plus 1, nothing to FOIL there. And that is my final answer. Let me move that up there. Sorry about that. So again, I had in the original problem missed the x minus 1 canceling with that one, and I didn't have it up here anyway. So I completely missed it. That was in there. And so I said I'd want to double check, and so that was good that I did. So that was my only thing left in the denominator, and there is my answer. If we're going to do domain restrictions, it's a lot to consider. And we have some extra ideas here. So denominator x cannot be 2. I agree with that. And in this one, x cannot be positive or negative 1 because 1 or negative 1 squared would cancel out. I lied again. X can be positive or negative 1 because 1 plus 1 is 2. So, all right, now let's try again. Down here, from this denominator, x cannot be positive or negative 1. There we go. And then if we look at this piece here, x can't be 0 because that came from our numerator. And we'd have to work at this to see, so I'm not going to worry about this domain restriction, but it doesn't factor, so to find this domain restriction, you would definitely have to use your quadratic formula to set it equal to 0. So that would be one that would be a little bit more effort, and then x cannot be positive or negative 1 here. So again, we would have to go through and do the quadratic formula, or completing the square, or another way to solve this since we can't solve by factoring. But that is a good idea of your domain restriction without looking at that piece there. Okay, so I apologize for the errors. Good thing we double check our work, and I appreciate you tuning in.